Hey, I'm Chris Zepp from Make Everything, and today we're going to bring this old vise back to life. Check it out. Okay, this is a Chaz Parker 205P, and the biggest atrocity on this thing is right here. So the jaws for these vices are notoriously hard to find, so the only thing I can assume is that somebody at one point lost the jaw and decided to weld this piece of rebar on there. The first thing we're gonna have to do is get this stuff taken off, these two jaws, clean this up, and then clean up the rest of the vise. Let's get into it. All right, so I decided to do most of this project outside. I really don't like to grind and wire wheel in the shop if I can avoid it. So I started off just with a cutoff disc on the grinder and a hammer to try and get this rebar jaw off. The vise is cast iron and it really doesn't hold a weld that well unless you really know what you're doing. Since I can assume that whoever welded this rebar on there didn't really know what they were doing, I knew that it wasn't going to be too difficult to get off. It's just a matter of trying to salvage that jaw. It's a lot of work with the grinder. It's a lot of sort of trying to revive the squareness of the jaw. These are cut at an angle, so that's sort of another thing to have to mess around with and try to keep true to how it was originally made. The other jaw is the factory jaw, but again, somebody welded it. These jaws were originally held in place with pins, and once I remove the pin on this jaw, I also just have to do a little persuasion with the hammer to get it off. With that jaw off, I can go ahead and just sort of fix up the vise a little bit where the welds were, grind some of that residual weld off, and start to take apart the actual vise. These vices come apart pretty easily. They're very simple. You've got a lead screw and you've got the lead nut in there. There's a big bolt that keeps the bottom base on and the swivel bolt, and these have a built-in vise wrench. So getting off that big bottom bolt on the bottom was a pain. It was 1.5 inches and I didn't have an 1.5 inch socket, so I had to sort of try and make it work with some adjustable wrenches. Not ideal, but in the end it wound up working. I had to bring it inside and use the other big vise in the shop to get a hold on it. This vise weighs like about 85 pounds when it's fully assembled, so it's not easy to move around. Once I crack the seal on that big bolt on the bottom, it comes right out, and just sort of checking everything, making sure that nothing's too damaged. And then you can see the swivel lock, and it's basically just a little cam. You tighten that bolt and it puts in a wedge that spreads out those two rings, and it acts like a disc brake. And now just getting the lead nut out. It's on a dovetail, so it was pretty tight. I just used a little piece of scrap metal to bang on it to knock it out. With the vise disassembled, I just had to take off the lead screw, which is just held on by a little clamp. It was time to start stripping that old paint off. For most of this, I used a wire wheel, 2 different ones. This is just a crimped wire wheel in sort of like the disc orientation, and eventually I switch over to a cup wire wheel. This works really good to strip off paint, but you have to take extra precaution to keep yourself covered during this. It probably took me 2 hours to get all the paint off, and during that time I maybe had like 40 or 50 strands of the stainless steel wire stuck inside my welding jacket. This stuff will get in your skin. It's not great. You'll find it for days after you're done doing a project like this, but it works really well to get inside all those nooks and crannies and get all that old paint off. and any corrosion and stuff just gets blasted away by the wire wheel, which is also really nice. You got to be a little bit careful with these things, because if you try and get in too tight, they can grab and kind of throw you a little bit. But for the most part, as long as you get a good grab on your angle grinder, you can keep them from getting out of control. And I just went over the lead screw and the handle as well. Once the big parts were done, I decided to take the rest of the small parts inside and use them on the bench grinder to get the wire wheel into some of those smaller pieces that I could hold with two hands. You can see in the background I've got my air filter running as well. Just, I don't really want to breathe in everything that's coming off of these parts. A lot of it's old paint and rust, and it's not great to have in the air. With everything stripped down, I can do a test assembly and get myself ready to start working on the jaws. So I throw that lead screw nut back in there and hammer it back in on the dovetail. And I put the base back on. I'm not being too careful or crazy here to make anything super tight. I'm just trying to get it assembled so that I can make the jaws as though they will be actually used when the vise is back in operation. Okay, so I did my test assembly. Everything looks good. Now, my next task is to make new jaws. This is the jaw that I broke off. And the jaws for these vices are notoriously difficult to get and notoriously difficult to make, because they're sort of not the same. You know, this angle is different on both sides. Like this jaw doesn't really fit on this side. So I'm going to make new ones out of this. This is 1.5 by 2 inch solid brass. So what I did was I took a piece of wood and I made it that exact size, and then I did the procedure that I'm planning to do on the Bridgeport on this, and this gives me my proof of concept. So basically what this wood is telling me is that I will be able to make jaws out of this, and I'm just going to have to run a pass on the mill to get them both flat with each other and do a good amount of shaping on the top, maybe with a grinding wheel, but it is going to work. So let's go ahead, take this material and turn it into these. So I start out here with some layout on the brass. It's always a little nerve-wracking. This is about $100 piece of brass, so I was a little hesitant to start on this, but you know, you just have to do your tests and get right to it. Don't hesitate. So after I made the wood mock-up, I knew it was pretty much going to work, and I did my layout with a caliper just to make sure that I could line my end mills up. I'm not really going to try and indicate this or do anything with the DRO because it's sort of a rough process, but I cut it down to a rough length on the bandsaw, and I just deburr it and get it clamped up in the milling vise. I'm using a 5/8 inch 2-flute solid carbide end mill. I know I probably didn't need to use the carbide, but I got a ton of end mills from an auction, so I figured this is what I had close by. Why not use it? I utilize my Bridgeport's power feed on this, and I'm taking a pretty good cut, running at a pretty high RPM with the power feed running at full speed. So it's just getting me through the cut. I'm roughing myself down, and then once I get these roughing passes done, I just use the lines that I scribed onto the brass to get my cutter at the correct height to do the final depth pass. And now at this point I had actually chipped the end mill. I don't really know how I did it, but it wasn't cutting that great. It's not a huge deal though, because I'm going to be going back in here now with a dovetail cutter and basically removing all the material at the bottom side of the cut anyway. So this is a 135 degree dovetail cutter. I want to say it's an 8-flute. To be honest, I'd never used one of these before, and I was kind of surprised on how long it took to make the cut. I guess with this many flutes, that's to be expected, but I'm not really sure how I could have improved my speeds and feeds to make this a more efficient cut. I definitely had to really take my time to do this, even though it was brass, but in the end it worked out fine, and the surface finish was actually pretty good. Okay, now that this is cut, I need to split it. So again, just doing some layout with the Dicom and just drawing a line right down the middle. And then I'm just using my Portaband to split this down that line. If you take your time with a Portaband, you can actually get really accurate straight cuts. So once they were cut down, I just sort of placed them on the jaws and saw that I had a ton of adjusting work to do. And now it just came to a lot of trial and error over on the belt grinder. So the angle that I cut with the dovetail was not 100% exactly what was on the vise. And I had read that about these Parker vices, is that angle is really hard to approximate. So a lot of the guys that remake vintage vice jaws avoid the Parker vices because their customers aren't happy when the jaws don't fit. So I had to do tons of testing and fitting, grinding and fitting and back and forth from the sander to the vise until I finally got something that was close enough for me to call it good. So once I had the two vise jaws pretty close, I closed the vise up and looked at it and thought, all right, that's not bad. That was at the end of the day. The next day I looked at them again and I thought, I could get these better. So I decided to take my adjustments from the vise jaws to the actual vise itself. So I started at it with a Patron 3M grinding disc. It's an 80 grit. And I basically just tried to take these jaws and make them a little more regular. They had a couple waves in them. They were causing the soft jaws that I made to wobble. So I basically just did it by eye and by feel, grinding down a little bit at a time using both a cutoff wheel and a flap disc. I know you're not supposed to grind really with a cutoff wheel, but I found that the rigid, flatness of it allowed me to really nicely and finely shape the vise jaws so that they would fit my soft jaws really, really well. I wanted as tight of a fit on this as I could possibly get so that I could, have the best performance out of the vise and not have anything wobble or rack on me. So you can see me going back in there with the grinding wheel a little bit too, the cutting wheel, and just getting down some high spots. Checking for a wobble and then just taking down that high spot with the grinder as best as I could. There was just a little weld spot on the base that I figured I might as well get off while I was dealing with all this stuff. Now the next task was to get the pinholes drilled. Like I said, the original jaws were held onto the vise with steel pins. Now I found the best way for me to get the pinholes located was to clamp the soft jaws on and then use one of these really long locating bits to drill up from the bottom. The drill bit size on this was a little over 1/4 inch, which was nice because I used a 1/4 inch locating bit to drill up through the bottom and gave me a nice rough estimate of where these holes had to be, and they were at the proper angle to fit through the vise jaws. It would have been almost impossible to do this from above with a blind hole. So just using a clamp to keep everything in place, I'm now going to chase those holes that I drilled with a 1/4 inch with the proper size drill from the top down and let the material guide me into it. Okay, so here's what just happened. I am an idiot. So this is the A jaw for the A side of the vise. I just did all of that on the B side, and I panicked because I thought that I had ruined this. But turns out that these holes line up perfect. Now this one is going to be even more difficult for me to drill from the bottom, so I'm thinking about drilling this side from the top and maybe this side as well. So let's see if we can't salvage this potential really bad mistake.
So again, I made my little error, and I was able to use the soft jaws as a drilling guide to drill down from the top and open up those holes a little bit. Thankfully that worked.
Okay, we're good. I can't believe it. Salvage the A jaw. Now I'm going to go back and actually do the correct jaw for the B side.
So even when you're labeling your parts and making sure that you're doing things in the right order, it's easy to make a mistake like that. But luckily I salvaged it. And here's just a little bit better of an angle where you can see using that long drill bit to take the drill angle and reference it off of the actual vise and drill up through that brass.
Okay, so here's a quick little tip on making a custom metal dowel. So this is the drill bit size that I use to drill through the jaws into the vise. And I'm going to take this 1, 2, 3 block and set it up on a taper so that at the finish of the taper, it's the distance between the belt that the drill bit is. At the beginning of the taper, it's a little bit thicker than the dowel that I'm using. So basically what it's going to do is, as I'm grinding, it's going to force this down to the correct size. It's a little tricky to set up, but once it's set up, it works really well.
So this little trick works really, really well to get custom sized metal dowels. You can also pretty much do it with wood or any round material, right? You can actually start square and do the same process, but I needed these dowels to be the perfect size to fit this drill bit, and these are a high-grade stainless. I don't remember the composition, but they're going to work really well for this application. They're going to be really, really strong, much stronger than the actual brass soft jaws are. So I ground down a long enough section to make myself 4 dowel pins, and then I went over to the porta band. I set up a stop block so my dowel pins would all be the same length, and I cut them to length. I decided to start with 2 dowel pins and get the first set of jaws in. This one located really, really easy. I had to do a little bit of adjusting. Basically, I didn't really deburr the bottom of that pin well enough, so I had to go back over to the sander and just grind down the bottom, put a little taper on it. But these wound up making the jaws really, really tight, which is exactly what I wanted. The opposing angles make these jaws lock in really nice. And then if you ever need to remove them, you can knock the pins out from the bottom and put a different set of jaws on if you wanted to. So this side took a little more effort to get the pins fitted. I had to put the pins in and eventually actually leave one long and then cut it down once it was fully installed. Now I'm just making a pin that stops the Acme nut from moving backwards when you loosen the jaw. So with the jaws properly fitted, this was my favorite part of the restoration, was grinding them to their final dimension. I left the jaws square and I really wanted to give them a nice rounded look to match the actual jaws of the vise. So the soft jaws are going to get grounded down to match that curve. With the steel pins installed, there's no reason to take them out. And once I had them ground, I wanted to cut them so that they were both square with each other. So I took a grinding and cutting disc and I just ran it straight down in the jaws while they were tightened. And what this did was it basically made them both be cut at the same time and reference off of themselves to get a nice flat surface in between them. Once that was done, I took a little bit finer grit of a flap disc and just continued to shape them and get them profiled and refined, grinding off the sides, the bandsaw marks, and sort of deburring the corners, making them a little bit rounder. I then went and did a little bit of work on the inside of the jaws as well, just sort of flattening them up from anything that may have come up from that cutting wheel operation. The brass is obviously really soft, so I had to be a little bit careful, and I also decided to grind sort of the heel of the vise, which can act as an anvil if it needs to be, and it was pretty marred up, so I wanted to clean that up. I took the wire wheel to the brass jaws as well. It gives them a nice sort of like orange peel finish. I wound up hitting these with a couple more finishing steps. So right here I'm using a polycarbonate paint stripping wheel, and this actually wound up being my final finish on the vise before paint. So I took this over all the surfaces that were flat and that would touch other metal surfaces, and this brought me one step further than the wire wheel and gave me a really nice smooth finish without taking any material off. That would be considerable. So this is just a cheap polycarbonate wheel and had chunks flying all over the place, but it did the job. Now it's just a matter of masking off the whole thing so that I can paint it. I made sure to cover any of the parts that were going to be metal on metal rubbing against each other. I wanted to make sure that they could not be made a little bit larger by the couple of coats of paint I was going to put on it. I didn't want to have any tolerance issues. And originally I was going to take off the brass jaws, but it just turned out to be too much work with the way the pins were ground perfect. I didn't want to ruin that, so I just decided to mask them off instead. I took off the base one last time and covered up that well with blue painter's tape so that I could keep any paint from getting in there, potentially messing up the movement of the vise rotating. And just knocking out the dovetail. Once I got everything masked off, I took it outside and gave it a bunch of coats of some Rust-Oleum hammered paint. This stuff actually holds up really well. I've used it a bunch before, but I made sure to give it time to dry between coats, and I gave it probably 6 coats altogether. Once it was all painted up, I actually gave it a full 48 hours to dry, which is what the paint can recommended, and I noticed that after 24 hours it was still tacky, and I was really glad that I gave it the full 48 hours. So throughout the day I gave that a few coats, and while that was drying up, I went inside to the big buffer and I started working on the handle. I decided not to paint this just because your hand's always going to be on it. I didn't want to give it a reason to get worn down, so I buffed it up and it actually turned out really nice. I didn't do any sanding, just the wire wheel and the buffer, and everything polished up and got to a nice polished finish. With everything painted and having 2 days to dry, it was time for the assembly. This vise is pretty simple. Everything you see on the table is every single part to it. There's really not that much to it. And I just start by ripping off all this blue tape. This is my least favorite part because I always feel like the blue tape comes off a lot harder than it went on. But it's really no big deal. And then getting the tape off the jaws for that reveal of seeing how the brass pops on that hammered paint just makes it all worth it. I really like the raised lettering on these vices, and from the second I saw it, I knew I wanted to do gold lettering. So here's a really easy trick. I'm using an oil-based paint marker, and if you have the raised lettering, it makes it very, very easy to give you that, gold or white or silver, any color you want. You can color in the lettering, and it just totally gives you the contrast and makes them just look so beautiful. I was really happy with the way the gold turned out on the hammered paint, and it just totally brings this thing a new life. Like I said, it's like a race car. I love the way it looks, and makes me not even want to use it. The rest of the assembly is pretty straightforward. I decided to put some red and tacky grease on any of the parts that were going to be metal on metal. I made sure not to grease the lock that will keep it from rotating. Obviously, I want that to get a nice firm lockup, so I was careful to keep the grease off of there. And put grease on any of the threads, anything that was going to get tightened, just to make sure that everything was nicely lubricated. And I decided to tighten down the swivel a little bit before adding that central nut that keeps the swivel base attached. Using my ghetto 2-wrench method to get everything nice and tight. I'm knocking in the dovetail for the last time, and I get the little pin installed. I throw some grease inside those threads, and I can finally put the movable jaw back in. I made sure to grease up this Acme screw a lot, and then I also added the 2 washers that go between the vise body and the handle, and I put some grease in between those as well. The last piece is the clamp for the handle, and this restoration is done. I'm really happy with how this came out, and even though it looks like a show pony, it's definitely going to get used. One of the next projects I got to do is I got to make a really nice stand for it so that it has somewhere to be dedicated, and I'm excited for the soft jaws because I hate having knurled steel jaws marking up my workpiece. These are going to be awesome for my workflow, and this is going to be an amazing addition to my shop.
All right, that about does it for this video. I really enjoyed this project. It's been a long time since I did like a full restoration like this, and after doing this, I really want to do more. I hope you enjoyed it. I'm so happy with how this thing came out. If you like what you saw, like this video, share it. Don't forget to subscribe to the channel. If you want to see behind the scenes stuff, I posted a lot of content while I was restoring this on my Instagram, and you can follow that here at Make Everything Shop. I got new shirts in my web store with a new logo, same thing on the back. If you like them and you want one, check out the link. Everything's below. Thanks again so much for watching, and I hope to see you on the next video.